And yes, we will see together some insight about the last generation of large language model. We try to understand together how they work, and from there, we'll see how we can interact with them. Because as you have just said in one of the last questions asked to Paul, yes, they may be quite large and quite difficult to be embarked on your own system because of the size. But nevertheless, there are ways to interact with them and to help them focusing on your task and on your domain-specific documents. We'll see that. Um, so until the end of last year, when I say I was a geologist developing artificial intelligence solution, I was only of interest for some few geologists and some few data manager, but all the other usually gave me just a rueful smile. They knew that they were not like I do, but working on serious subject where artificial intelligence could only give low confidence transfer, and when only the experts' knowledge, intelligence was really useful. But I've noticed that after the last November 3rd, when OpenAI 30th, when OpenAI launched ChatGPT, the things have changed. And that is because all of us very rapidly have tried out this new chatbot that was supposed to provide acceptable answer on anything and everything. And we saw that indeed ChatGPT gave acceptable answer on anything and everything, including for the energy sector and subsurface or area of expertise. So that changed a lot of things, and a lot of people came to me to ask about your experience using large language model and how it could be useful in subsurface data management. So that's the purpose of this presentation. Okay, so like I said, beginning of last December, we have all tried to query ChatGPT on topic we know, and the first we can say that all the answers were quite close of the Turing test. Means that not only they were providing some acceptable insight to some level of details, but it was also nice to notice that the system was able to really interact in the conversation. So it was possible to ask a question like, what is the largest producing field in the North Sea, to get a reply, which may be acceptable, to ask another question, even with some typo, like here, and the system was able to elaborate from the second question, taking into account the context of the first question and the first reply, like here. So yes, not only the answer were interesting, but we have for the first time a real capability to interact. And on very on a lot of subject at the condition it was you were not expecting too much level of details, but it was nice. Obviously, sometimes the same fantastic chatbot may have failed, and you have seen probably plenty of failure. And I have tried to group the case where a system like ChatGPT failed. And in fact, I consider there are three main categories of failure. The first type of failure is when the reply you are expecting is not based on the knowledge of something, but much more on the reasoning. And a system like ChatGPT, and we will see together why, is not designed for reasoning. It's designed to generate information based on the knowledge he has accumulated, mainly from the web. So reasoning is not his first capability. Second limitation is that these models are very difficult to be updated and very costly to be updated. So that's the reason why, even if you are asking question based, expecting a reply based on knowledge, if the knowledge is quite recent, and that is a query I've done for this presentation, so it's a query I did a few days ago. If it's really in the information is in the last news, it cannot be, the answer cannot be correct. And finally, another limitation, if it's when you are asking for something very specific about your domain. Here, I don't know, I am asking a question about a particular drill hole of the Dutch North Sea, and you know, the ChatGPT has not been trained particularly on the Dutch North Sea documents and is completely unable to reply correctly. Nevertheless, he can give some advice and where I could find the information. Okay, so three categories where it cannot work. So why such a system can be fantastic and completely fail on some case, on three particular cases. We try to see that together, and to see that, we'll work as an engineer. We try to see what is in the engine. Okay, first basic things to know is at first, ChatGPT is a chatbot. In other terms, it's a conversational agent. In other terms, again, it's a generative intelligence. It's something which is able to generate content according to a context. So it's an intelligence which is trained to generate some new content. To be honest, until the inception of ChatGPT, most of the chatbots were not very efficient because they were just based for the first one on rules, or just on the similarity of term between a bank of question and a bank of answer. And these techniques were not very efficient. So why ChatGPT is much more efficient than any other chatbot? It's because with GPT inside. GPT is stand for for generative pre-trained transformer. It's a deep neural network which can be trained to provide answer. We'll see how GPT work. So I'd say it's a generative pre-trained transformer. Generative because its purpose, again, is to generate something which is not pre-existing. Pre-trained because you can use it directly, has been pre-trained on a large corpus of documents. And transformer because it's a deep learning model of the class of transformer. And transformer is, we'll see what is a transformer in a few seconds. So it's a deep learning. What is a deep learning before to continue and see what is a deep learning transformer? A deep learning is something quite simple. Here I have I have make it very schematic. It's a system of neurons, and you can add some other operator if needed. But to make it simple, just remember it's a system of neurons more or less connect together in this one. The few neurons we have here are all connected together. So we say it's a fully connected system, which is trained to perform an action. Here, for example, the system has been trained to recognize, to classify image of cats and dogs. How that works? How works this kind of training? So at the beginning, you have just what we name an architecture of neurons. So a certain number of neurons, you can group here in layers. Here, all the layers have all the same number of neurons, but you are not obliged to have this schema. So you define an architecture of neurons. You select a way you will combine your neuron together. And after you start your training, so you connect the pixel of a cat image, for example, if you start with a cat, choose a neuron on the left here, the entry neurons. So you connect the pixel to the neuron, and you will adjust all the weights of the neuron in order that they will transform the signal from the pixel into a pair of value, because we have just two neurons at the end, where 1 here and 0 here will be a cat. So you will authorize the system to adjust the weight when you provide a cat image until you get something close to 1 here and close to 0 here. Then you can continue with another cat image or with a dog image. You, for example, will supply a dog image. You know it's a dog, so you can force the adjustment of all the weight to have to end here with the 0 and the 1. So training is just about adjusting the weight of a big neural system. Okay, so how that could be used to reply to question? Can I use it with question as an input and reply as an output? In fact, no, because this problem of expecting a good reply to any query is much more complicated than recognizing dogs and cats. When recognizing dogs and cats, you have, in this case, in this very basic case, you just have two categories in the beginning and two categories at the end. So the number of categories is very limited. You can imagine that to build something like ChatGPT, you have something which is close to the infinite number of possible query as an input, and as many possible reply in the output. So it's not possible to expect training a system with so many query and so many reply. In addition, providing the good reply to the query will need an army of experts to make this pair of training data, query and good reply. And it's something which is not a second reason why you cannot have this brutal approach for training a deep learning. And here comes the idea of the transformer, because with the transformer you will do something much more simple. A transformer is a large it's a large neural network, I will say, even if they are not only neurons, but it's a large deep learning system trained to do a very basic task. The only thing to do a transformer is to find what is the next word. So if you send a prompt like the mouse has been eaten by the system has only one thing to do, it's just to provide the next word. And if you have a well-trained transformer like GPT, the system will reply probably cat with a confidence of something like 88. You can notice that it will not reply, it may not reply cat at 88. It may say dog at 20, snake at 6, lion at 1, crow at 12. Okay, so which are something which is less acceptable answers than a cat, but acceptable answer nevertheless. And you can see here from this first point, and a transformer is not something trained to give you the truth, because you don't know what has been happening this morning in your garden. Who has eaten the mouse? Maybe it was a crow, or it was or the dog. You don't know, and ChatGPT will not know, cannot know, but it can provide you something which is reasonable, something which is in line with the web literature. And in the web, frequently the mouse has been eaten by the cat. And that's the reason why we reply the cat. So again, the purpose is not to give the true answer, but an answer in line with the training set. The advantage, so even if that cannot give you always the truth, but just something acceptable, it has a big advantage. It's a system which is very, very easy to train, because sentences like that, you have trillions of sentences in the web. So it's easy to extract trillions of sentences, discard a word or two, and have the system trained to find this word So the training is something which is said to be semi-automatized. It can be done, the training itself will not involve experts. It can be done by the machine itself. So that's a big advantage of the transformer. It's easy to train. It will take a lot of time. It will take a lot of resources, because you have to provide a lot of sentence, but you have the web has almost no limits in the number of sentences to be they name that prompt to be provided. So it's
Henri,
easy to train. Yes.
Sorry, you have 5 minutes to wrap up. Thanks.
Oh, I will have to fast up a little bit. So easy to train. Okay, plenty of sentence. And because you can provide a lot of training data, you can also imagine a neural network with a lot of neuron, a lot of parameters to adjust. I told you in the beginning of the 2000 to retrieve the cat and the dog, we were using neural networks with hundreds of parameters, and now we are discussing about trillion of entry and trillion of parameter for training the system. So it's a very huge neural network. That's the reason why you cannot transfer it to your laptop, because it's too large. It's also explained why you cannot work with the latest news, because it takes several months to be trained. And so you cannot, retrain every day to add the last news in the system. And the question is, does it work? So to know if a transformer works, the best is to test it. Remember that the purpose is not to give you the truth, is to give you something acceptable. So if here I'm using the GPT, it's not ChatGPT, just GPT playground. So if you put a prompt like Christopher Columbus discovered America in, obviously now you know how that works. It will give you a high probability to have as the next word 1492. With also the possibility to have October, because yes, that Christopher Columbus has discovered America in October. So October is there. The difficulty with this kind of system is that if I replace Christopher Columbus by my name, I will get exactly the same answer. And that's because GPT is enabled to really analyze the prompt. It will take the prompt as it is. And in the web literature, the inference between discover America and this date is so strong that it will make the same result, whatever the name you put here. And that is a limitation. Really, it's there are some bias in the training data set, and they are very difficult to point and to eliminate. How to go from ChatGPT to from GPT to ChatGPT? To do that, it's very easy because GPT is providing the next word, so you can loop on that. You can take this next word and ask the system to consider the concatenation of your initial prompt and the next word as a new prompt, and you ask the system to continue until you decide it to stop. And that works. Here, you know, I have put silver unicorn were finally spotted by scientists in the earth of Amazonia, and GPT will continue on that. It may be a completely hallucination, but it can continue and provide you something which is semantically acceptable. Obviously, if during this training you have provide web content which is completely stupid, it will create a completely stupid answer as it is. How to solve this issue? Because you don't want in your organization, you don't want a GPT or ChatGPT providing answer about, I don't know, silver unicorns where you are hunting for oil and gas fields. So you have three tools to adjust a very large language model. Again, you cannot retrain them yourself. You can train yourself some smaller one like GPT-2, for example, or BERT, but for a huge and large model like GPT-4, it's not possible for most of the organization. But you have three tools. First one is what we name the pre-prompt. As an entry, you can provide a prompt which is quite large. With the last version of ChatGPT, you can propose a prompt of 32,000 of words. 32,000 of words is something like 100 pages, and you will never put a question of 100 pages. Your question is of maybe 10, 20 words, rarely more. That means that there are rooms before your prompt to put a text, and this text will be concatenated with your own prompt and will prepare the system for giving you an interesting answer. Pre-prompt is something the large language model organization are not very interested to provide, and we know that they change them frequently. They are continually adjusting the pre-prompt. But here is the preprint of Sydney, which is the being use of GPT, has been hacked in last February. And you can see what's the content of a preprint. It's just some text advising GPT to prepare the answer. Nothing that, but just giving instruction to GPT to provide you something which is useful, not stressful, and things like that. So it just the preprompt is just a raw text in English, helping GPT to provide the right answer. It seems very basic, but in fact it's very, very useful. And you can define your own preprompt and directly use GPT, your prompt, with your own preprompt before. And in your preprompt, you can define information about the style of the answer or the topic of the answer. That's the first.
Henri,
Yes.
we have to move to your conclusion and close
Okay.
our statement.
Okay.
Thanks.
I will do that. So, second tool is the fine tuning. So you can add some additional training to GPT. So you can provide few query and answer to the system. The limitation of that, it's work, but today the systems, the large language model are so large that it's quite difficult to do that simply, because you will need a lot of additional entry to specialize the chatbot to your system. So there are some techniques to do it, but it's a little bit sophisticated. And finally, the last tool you can do is to define a feedback system. So you can let your large language model providing some reply. You can ask a labeler to rank the reply, and so you can train a reward model you can inject in your large language model to give some preference to some answer. And it's another way to adjust the model. So I have no time to give you, because my idea was to give you some geological example, but I'm running out of time. What I can go directly to the conclusion. Thing that today generic large language model can be adapted to, can be trained specifically to a specific domain. And they can do much more things than just a chatbot. They can make abstracts, they can classify your documents, they can detect some punchline in your documents, they can make some resume, and so on. The large model are trained automatically, and you can add some additional training. And to do that, you need a good user interface for an expert to provide easily some additional training to the system. So user interface for us at AgileDD, we consider that the user interface is key for improving a model. And we consider that, yes, this model today can provide you some accurate information. In order to make this accurate information something trustable by the end user, you really need to involve the user in the loop of the training. So better to involve the data manager, the data owner in the training loop, so they will understand, they will feel the bias, and they will immediately know, as it was explained by Paul previously, what to do, what has been happening in the model, why the answer is not exactly as expected, and they can react and adjust the model for that. And so that is my conclusion.
Thank
I'm
you,
ready
Henri.
to reply to any question.
Thank you. Thank you. One of the questions is precisely, but we're gonna open the mix for everybody, okay? So you can actually argue questions yourself. It will be nice to hear another voices than mine. But one of the questions are, what are your thoughts about the relationship then between the large language models and the data manager role?
Building, as I've explained, building the large language model may be done without, it's a semi-automatized job done by data scientists. So there is no role for data manager building the model, but then to fine-tuning the model, either by preparing the pre-prompt, uh, doing some fine-tuning, or on the top of fine-tuning, creating a reward model. That's the job of a data manager, because the data manager knows his data, so is the best person to uh, to um, to provide some annotation to some training data in order to guide the model. So certainly, the data manager has a role for tuning the model. And to do that efficiently, he has to understand how that works. Is not, if you go, if you try brutally to fine tune something like GPT-4, it will take decades. So you have to understand how that works. You have to have a user interface explaining to you what part of the model you have to is the best to train. I told you that there are today trillions of parameters, but you are not obliged to train all the parameters for any of your query. You can select some part of the model to be trained, some layer. So that is the minimum knowledge of for data manager to have, or if he doesn't have, uh, he has to work with a data scientist. And I think the binomial data scientist and data manager is very powerful to yield some useful artificial intelligence.
Okay, thanks. I have another. Luis, you want me to read the first one, or you read it yourself? Okay, I'll go ahead. Could we reduce the cost of updating such models by restricting their dataset to only relevant sources?
Yes, that's the reason why you are not. That's a very good question, and because we have to take into account the cost of these kind of things. So, is it necessary to use a large architecture like GPT-4 to solve problem in a small area? Maybe not. You're right. If you're working, I don't know, in the Dutch North Sea, you you have to recognize, you have to take into account maybe 1 million of documents, no more. So why using such a large model? There are several reply. Advantage of using a large model, it's because reading all the web, the model has learned the semantic in all language, in English, in Dutch, in German, whatever, in French. So that he will remember that. No, in terms of knowledge, better it's not, it's not necessary to know everything about quantic physics if you just have to detect some drill hole in documents. That's true. But that's the reason why, for example, frequently we continue to use model as GPT-2 or BERT to do some more basic classification and things like that. You are not always obliged to use the last huge large language model to perform a classification of subsurface documents. That's true. You have to find the best ratio between cost and accuracy.
Precisely. Well, in this case, we have a session also, which is for networking. I think we can continue talking about ChatGPT in the area of networking. Henri, thank you very much for your presentation.
Okay.
I have more
Thank
questions
you.
here. I'll collect them and see how we can answer all of them.
Oh,
okay.
I can reply them on the Slack.
Okay,
I will
perfect.
go to the Slack in the day to come.
Precisely that what we were thinking, to put it in Slack and then continue with the discussion. So Tracy, let's see how we can go into our networking. We are trying this for the first time we tested it ourselves, but it's our first time that we do an online networking. It's not as simple as doing it face to face with a glass of wine, but anyway, but I think we will. Let's close out with a conclusion about this second one. And one thing that I like a lot and read and I wrote down was reasoning, that
yes.
AI and ChatGPT and all these kind of things are not designed for reasoning. And
no,
thanks
that's
God,
true.
we are the one who have the reasoning, So we still
yes.
have and I'm pretty sure governance has to be established. The strategy in the companies has to be established. How do we, keep people for, keep our data private? All the legal unlimited, stuff that we have in every country about data privacy. So it's not as simple as it is. But still is giving us data managers a place to play there, and data quality is one of them. The fact that we have to collaborate with everybody to be able to do all these projects and give our expertise. We are the custodians of the data, and we are specialized in the data that we're using. So we still have a role here. But we have to look it with another angle, another type of classes, and see how we get better in there.